Now let's take a look at solving absolute value inequalities. Now you'll recall that when you solve an inequality, you get many more solutions that you do when you solve an equation. The same thing is true with solving absolute value inequalities. So let's think about what this means. The absolute value of something is greater than 7. Remember, absolute value means distance from 0. So we're talking about numbers whose value are more than, or numbers whose place on the number line are more than 7 units away from 0. So there's two ways that can happen. A number can be more than 7 units away from 0 if it is to the left of negative 7, or a number could be greater than negative 7, or a number's absolute value can be greater than 7 if that number is to the right of positive 7. So you can see what I've shaded here on the number line are all the numbers that are more than 7 units away from 0, so either to the left of negative 7 or to the right of positive 7. So when we go to write the solution to this absolute value inequality, we're going to write the union of two sets. We're going to say all the numbers that are less than negative 7 to the left of negative 7, or all the numbers that are to the right of positive 7. So that is our solution set. Again, it's the numbers that we have shaded in on the number line here below. Now, what about this absolute value inequality? So now we're talking about all the numbers whose absolute value are less than or equal to 5. So what that means is we're talking about numbers whose distance from 0 is fewer than 5 units away. So this time we're going to be looking at the middle of the number line, less than or equal to 5. So this time I'm going to put a closed circle on negative 5 and a closed circle on positive 5, because you'll notice this time we have this less than or equal to symbol. So that includes the numbers that are exactly 5 units away. And then I'm going to shade in all the numbers that fall in between those. So everything I'm shading here would be numbers that are fewer than 5 units away from 0. So this time we're looking at the intersection of two sets. We're looking at all the numbers that are at the same time bigger than negative 5 and less than positive 5. So we'll write our solution like this. We'll say all the numbers that are at the same time greater than or equal to negative 5 and all the numbers that are less than or equal to positive 5. So here's how we would write our solution, and here's how we would represent it on a number line. And let me add also that on these problems where we're looking at absolute value inequalities that are less than, you'll notice that we're looking at the intersection of two sets, all the numbers that are bigger than or equal to negative 5 and less than positive 5 at the same time. So we can write our solution like this, but for these problems, okay, where you shade in the middle of the number line, we could also write our answer as a compound inequality. Negative 5 on the left, positive 5 on the right, x in the middle, and then less than or equal to symbols in the two spaces. So x represents all the numbers that are at the same time bigger than or equal to negative 5 and less than positive 5. So we can't do this on the greater than the absolute value problems where the symbol is greater than, because then you're looking at the ends of the number line. So you'd have to write two statements joined with the word or. But on these, you can either write the two statements joined with the word and, or you could write it as a compound inequality. So now let's try this absolute value inequality. So notice that this time 6 is being added to the absolute value. So the first thing we want to do is isolate that absolute value symbol. So we will do that by subtracting 6 from both sides of the inequality, and we get the absolute value of x is greater than or equal to 5. Okay, so now what does that mean? Absolute value of x greater than or equal to 5 means that we're talking about a set of numbers whose distance from 0 is greater than or equal to 5. So that can happen in two ways, either to the left of negative 5 and including negative 5, or to the right of positive 5. So let's indicate that on our number line. So we're going to include negative 5. I'm going to put a closed circle there because of this greater than or equal to symbol. And then I'm going to shade everything to the left because those are all numbers that are more than 5 units away from 0, okay? And then we'll do the same thing on the other end of the number line. I'm going to shade in positive 5 and then shade the numbers that lie to the right of positive 5. So this number line indicates all the numbers that are more than or equal to 5 units away from 0. So the way we'll write our answer is we'll say that x is either to the left of or equal to -5, or x is greater than or equal to +5. Okay, in this absolute value inequality, you'll notice that the absolute value is isolated, so there's no initial step we have to do. So we're going to go ahead and rewrite this without the absolute value symbol. So if you think of an expression whose absolute value is less than 4, let's just draw a little number line to help with our thinking. Okay, so an absolute value less than 4 means that we are fewer than 4 units away from 0. So we're talking about this part of the number line in the middle. All the numbers that are at the same time bigger than -4 and less than +4. So we're going to rewrite this without the inequality as the intersection of those two sets. All the numbers that are at the same time greater than -4, okay, to the right of -4, and at the same time all of the numbers that lie to the left of +4. Oops, hold on, I made a mistake there. It's not x. Remember, our expression inside the absolute value is x minus 2. So we need to say that x minus 2 is less than +4. Then we will solve these two little equations, and we get x is greater than -2, and at the same time, we get that x is less than 6. So all the numbers that are both greater than -2 and less than 6 would be in our solution set. So I'm going to draw a picture of our solution set. I'm going to put an open circle on -2 and +6. And the reason I have the open circle is because this is strictly greater than and this is strictly less than. So that doesn't include -2 and 6. And then I'm going to shade all the numbers in between. So if I pick any number in this shaded region, any of those numbers would make this inequality true. Let's just take, for an example, 2. If I put 2 in for x, 2 minus 2 is 0. The absolute value of 0 is 0, and 0 is a number that's less than 4. So 2 and any other number in this shaded region will make this absolute value inequality true. And then again, remember, if it's a less than, an absolute value inequality that's less than, resulting in the middle of the number line, we're talking about the intersection of two sets. So we can write our solution a second way. We can write it as a compound inequality, -2 on the left, 6 on the right. X represents all those numbers that lie between -2 and 6, and so we would want to put a less than symbol here and a less than symbol there. So you can write your solution either one of these two ways. They're both correct. Okay, let's take a look at one more example, and the first thing you'll notice is that the absolute value symbol is being multiplied by 2. So the first thing we need to do is isolate this absolute value symbol. So what we're going to do is, since the absolute value is being multiplied by 2, we're going to divide both sides by 2. So what we get then is that the absolute value of x plus 3 is greater than 6. 12 divided by 2 is 6. Okay, so now let's draw a little number line to help us with our thinking. We have an expression whose absolute value is greater than 6. An absolute value greater than 6 means more than 6 units away from 0. So I'm going to put -6 on a number line and +6 on a number line. And then to be more than 6 units away from 0, you either would have to lie to the left of -6 or to the right of +6. Okay, so it's the union of those two sets. All the values that are to the left of -6 or all the values that are to the right of +6. So now our next step is we're going to write this as two inequalities without the absolute value symbol. So let's represent the left end first. We're going to take what's inside the absolute value and set it less than -6, okay, to show an expression whose value is more than 6 units away from 0. That would be to the left of -6. Or the other way that can happen is that our expression x plus 3 could be to the right of +6. So that would be greater than +6. So we will solve those two inequalities. We're going to subtract 3 from both sides. Oops. Okay, so we get x is less than -9, or when we subtract 3 from both sides in the other inequality, we get that x is greater than 3. Okay, so our solution set would be all those numbers that are either less than -9 or greater than 3. Let's represent that on our number line. So all the numbers that are less than -9 would be all the numbers that lie to the left of -9. Notice I'm putting an open circle on -9 because these are numbers that are strictly less than -9. That does not include -9. Or all of those numbers that are greater than +3. So open circle on 3 and then shade everything to the right. All right, so now you've seen some examples and you're going to try some problems on your own.